So again, thank you for allowing us to sponsor the conference this year. It's been really interesting. As a sheep farmer's son, obviously an ex-sheep farmer's son, it's been very, very good. So who is GEA? GEA globally has about a turnover of just over 7 billion New Zealand dollars. We do an EBIT of about 12.6% on that turnover, and we have about 17,000 employees. So GEA has really specialised in food and following the sort of macro trend of rising middle class, rising consumer needs, and that will provide business for us on into the future. So we're a publicly listed company in Germany, so we also have shareholders to... sorry? Not for me. Globally, we're present, of course, around the globe. I'm happy to say in Asia Pacific, we have the highest turnover of any of their 6 regions globally. Wrong button. So it turns out you're in touch with GEA every day and you don't even know it. Approximately 1/4 of all processed milk comes through a GEA milking machine or processing plant or dryer or packaging machine. Something close to my children's hearts, every 3rd chicken nugget is produced by our technology. Every 3rd process line of instant coffee is installed by GEA. And the next one you're probably all going to like. Every 2nd litre of beer is brewed with the aid of a GEA solution. Every 4th litre of human blood is handled by GEA equipment. And more than 1/3 of all polymer producers are using GEA drying technology globally. Utilities, about 1/4 of all wastewater sludge from petroleum and natural gas processing is dewatered by GEA high-performance decanters. And every 2nd container ship in the world sails with GEA marine equipment on board. So you can see it's really quite a diverse offering that we have, but here today we're talking about milk machines. GEA New Zealand has 440 employees, so they have come into GEA via acquisitions. So GEA Morphos, which I am a former member of, was purchased in November 2012. Before that they purchased FIL, the chemical company at the Mount. They've also purchased the Avipac, the packaging company which does all the milk powder in New Zealand. So it's a very aggressive acquisition path. Indirectly, we employ about another 1,200 service professionals, either with our service partners or contractors on site, putting all the equipment together. Milk from over 2.5 million cows is processed through our equipment. 300 tonne of powdered milk per hour is produced in New Zealand through GEA equipment. 85% of dairy farmers use GEA product. 2/3 of every spray dryer in New Zealand is GEA, including 2 of the largest 30-tonne dryers. 20% of all New Zealand farmers use GEA equipment, animal health products. And every 4th farmer cleans their dairy with GEA chemical. And 1 in 4 farmers in New Zealand extract using New Zealand milk machines. This is just a short video. I must apologise, it does feature cows, which I was told is a bit of a no-no, but until we get milk up and going, we don't have too much sheep footage. really that was just all about showing that GEA's in touch with the milk from farm right through to final consumer. A lot of our equipment's used in the dairy co-op to give an idea of scale of the goat industry as well. And as I said before, we're supplying Mana with their new equipment. And we also, I think, supply spring sheep with some homogenisers, etc. Coverage across New Zealand, we have 17 service partners across the North Island. We have 3 area managers, an effluent guy, and also a business development person. South Island, we have 8 service partners, 3 area managers, 1 South Island manager, and on the hygiene side of the business, we have 3 hygiene professionals as well. This is an example of a recent goat rotary. We put up, again, apologies, don't have sheep on yet. Goat rotary just outside of Cambridge. So this is an internal rotary, very similar to what we'll be supplying to the New Zealand market for sheep. This is just showing the headlocks in place on holding the goats in situ. So you'll see there's no actual dividers between the animals as such, hence the headlocks. And any of you that had experience with goats will know as soon as they're unoccupied being milked, they tend to turn around and start chewing things or jump down and come and visit you. This is a close-up of the feeding area. So the feed head, we can feed 3 different feed sorts, plus liquid. The feed is dispensed into these bins, as you'll see downstairs as well. These bins drop down into the bridge here, and any residue food gets dropped on the ground or into a collection area. We have a controlled entry to stop animals piling onto the rotary, and that's for photo sounds as well, so it keeps the rotary going around. This is the exit area, so the animals come on straight, of course, and they get turned around to make it an internal rotary. This one's had a space to put in there because the animals are very small at this stage. And this is the exit area with all the safety stops, etc., to stop animals getting crushed on exit. Another example of a relatively cost-effective low-line milking machine in a herringbone configuration, and a more sophisticated double-up system with milk metering, individual feeding, identification, milk metering, etc. And more sort of medium cost midline system. This one's the stallings produced here in New Zealand. No milk metering, no cup removers, so it's a very cost-effective system. Something we're supplying to Mana when they come on board is these feed bouts here. You might have seen one when you walked in the door this morning. We've supplied 6 of those, which are 59 metres long. They're capable of carrying 5 tonne of food. So the idea being that the food going to the stock is always fresh. So you pull in with your feed out wagon here, load the bout. The bout has a proximity switch here, so as soon as there's no feed being delivered, it stops and waits for the feed to come out through the feed mixer. So it has the added benefits, of course, of reduced barn widths, no machinery going through the barn, etc., and causing disturbances. Now I must confess this has got some, well, 2 things. The guy meant to do this presentation wasn't available, so I've been thrown right in the deep end. This isn't my area of expertise, so there will be no questions. This is very basic. So what the presentation is on is bacteria removal separators. So the applications for that for your particular industry. When you use milk for cheese, if you can reduce the Clostridial anaerobic bacteria, you're of course going to increase the cheese quality. When you use milk for drinking, we can extend the shelf life by a reduction of the bacterial spores present in the raw milk. When used for milk powder, we can also reduce the total bacteria count and then use a lower heat process to process the milk and try to retain some of that vitamins and goodness in the sheep milk. For UHT, we can reduce the high heat resistant spores that can even survive at 140 degrees Celsius. So it's ensuring a very high quality product even in UHT. For whey processing and whey protein concentrate, we can reduce the bacteria right through the process, so it has a very long lead time, long brew time at 35 degrees, so it's perfect for growing bacteria, hence we need to remove them. And the added benefit is, as you spin off all the bacteria, you get a reduction of bioform in the heat exchangers and evaporators, which means you need less downtime cleaning the equipment on the processor. So bacterial removal versus pasteurisation. So heat destroys the bacteria cells, but it doesn't destroy the spores. Spores, when the cell wall breaks, the enzymes and the spores come into the product. So here are these nasty little critters here, a bit of DNA there. So they are still present in the product after it's been pasteurised. They can have a negative influence on the product in its final form. Bacteria separators remove cells and spores. There's no chance of reinfection, and the enzymes are removed from within the cells when you take out the cells, so they're removed completely. And there's no flavour or vitamin losses because there's no, you can use lower heat treatment. The use of bacterial is highly beneficial with heat-sensitive products. So the mechanical separation relies on the different weights of the objects that are in the milk. So sheep milk is about 1.029 grams per millilitre. I've tried to give a bit of a visual indication of this here by showing the vegetable bacterial spores and aerobic spores and anaerobic spores having the different weights and sitting in water, which of course has a weight of normally 1 gram per millilitre. We can remove the bacteria in skim milk, standardised whole milk and skim whey. Many bacteria, moulds and yeast can be removed. To give you some sort of ballpark figures, the total bacteria count of between 200 million cells, we can reduce between 70 and 90% of all bacterial load in that milk. For aerobic spores, we can reduce it by about 90%, anaerobic spores, 98%. In somatic cells, we can reduce about 95% of those from the raw milk. But efficiency does depend on product, temperature, air content in the product feed, and reinfections, etc. So you must keep the milk once it's processed at low temperatures. For you cheese makers in the audience, I won't read this through, but I guess if you can pick your cheeses, these are some of the benefits you can have by getting rid of some of those bacterial load prior to processing into cheese. The process for drinking milk. So if we remove the Bacillus cereus, it's very important because those bacteria can actually survive pasteurisation. The bacillus multiplies in a very short time and can create something called sweet milk coagulation, which you guys may know more about than I do, to be fair. The removal of the bacillus spores improves the shelf life.
Continue for 2 kilometres.
You're seriously lost. You can integrate it prior to or after the hot milk separator. The influence of high amount of somatic cells on product. They can contain enzymes which affect fat and protein, of course. If we remove those, the protein content decreases. We get fat in the way and off flavours. Sorry, that's if we don't remove them. So they can also influence the coagulation time. You can get delayed acidification, so more time is needed to actually produce the product. They also affect the texture, so less whey drainage, there's a higher moisture content in the cheese, softer and higher risk of bacterial contamination, which therefore leads to a shorter shelf life. So it has a high impact on product quality. This is a short video showing how it actually works, so the video does tell 1,000 words. This thing's spinning at about 10,000 RPM. you'll see it move down through. So the red dots are obviously signifying bacteria, spores, etc. That red stuff is the sludge, the bacteria, the spores, etc. And you set a timer between 15 minutes and 60 minutes to basically open it up. That spins out into the outer shell and then goes to waste. It's held together by sealed by water. Pressure in, pressure out, so this is being pressurised up to the static pump head, which is a centripetal pump. That's spinning at 10,000 RPM, so the pump, as it's called, pump head doesn't have to spin, and then it repressurises the liquid. So in terms of processing, we can do it from 3,000 litres an hour through to 60,000 litres an hour. To give you an idea of cost, the 3,000 litre one is about 200,000 Kiwi. So it's not a cheap bit of equipment, so I guess if you can freeze the milk and get it all in one place, it may be economical. So the advantages, wide range of dairy applications. These are used in Spain on a mixed milk model. So the factories will process all types of milk and use this process across the various types. There's no negative influence on the vitamin content or taste. Short cleaning cycles and long operation times compared with filtration. And by that, that is of the unit and also of all the associated plant that comes off the unit. It's easy to integrate, it's pretty much a drop-in system. We can actually use double bacteria removal as well to increase our offtake. Can you get the next slide for me? Yeah. So this is an example of a double bacteria separator. So we come into one, which reduces about 90% as per those figures you saw before, and then the second one will take out the extra to get you to sort of 99% of the Bacillus cereus, etc., removed from the system. And that is the end of the presentation, if it will let me. Any questions? One of my service partners is back, is waving his arms enthusiastically.
Thank you. I have two questions. So you're not losing any proteins or lipids with this process of basically spitting out?
No, because there's no heat, although it does work. I was told it works better if the raw milk coming in is warm, because you also get increases the viscosity, so the bacteria is easier to remove. But anything from 35 to 50 degrees, which is body temperature and up.
My second question is, by removing the somatic cells, don't you kind of indicate to the producer that adult health is not that important because you can just fix it up in the milk later?
I shouldn't tell you this, but I had one customer in South Africa, did exactly that. He milked everything into that, spun it out, and he was an A1 supplier. Yeah.
Yes. Yep.
Okay, so now, what about the vegetation factor on the milk?
I'd like to say I knew enough about it to answer that question, but I don't. But these things are used, they're used in all of the milk factories in New Zealand. It's not a new product, it's been around for a long period of time.
Not sheep milk.
Sheep milk, we use them in Spain, in that mixed milk model. So they're processing cow's milk, sheep's milk, goat's milk, all one factory processed of many types. So I'd have to believe the experts and say that it doesn't cause protein degradation, but don't know. I can find out for you though, definitely.
Yeah, I have a question. I'm just wondering about from the regulatory point of view, is this a process that is kind of compliant with MPI regulations for?
It's used in all factories in New Zealand, so yes, I
Okay.
presume so.
Thank you.
It's not a new product,
Okay.
it's well established. Yeah. But I guess what I'm trying to point out here, it seems to be from where I sit, sheep milk is a very expensive, high quality product. We're denaturing it by heating it up, UH10, etc. We could guarantee our customers we're giving them an unadulterated product straight from the sheep. I'm talking before about iodine, etc. Some of these things all disappear when we heat it up, so it seems a bit silly.
So does it have any impact on your requirement for pasteurisation? Is that like you pasteurise at lower temperatures, or what is that all? And then how does that obviously fit in with your RMP?
I think we'd have to look at it for your industry, because I know when the Dairy Goat Co-op looked at it, because it wasn't, we're 99.9%, but because there's a 0.1% chance of some bacteria coming through or some Clostridia with the goat case, then they still treat it, but it would depend, and they're purely on powder, but it'd be interesting to know if you put that product into cheese, if that process would get rid of any chance of that happening. But I guess the fact of extending shelf life, etc., by removing it from the raw milk, we'd need to, I don't have all the answers for you, but I can certainly find out more. But it seemed logical to me that if you remove all that bacteria to start with, and that's what talks about, the pasteurisation breaks the cells, but releases those spores, which are still in the milk and causing the taints and the aging of the milk. Australian, I expected a few questions from our cheese producer.
Great, well thank you very much, Jason. Awesome.